We are given a circle and two line segments that are parallel to each other. Distance between those two line segments is 6 units, and one of the line segment is chord of the circle, other of the line segment is having length equal to 18 units, and one of the endpoint of the line segment lie on the circumference of the circle. We want to determine radius of the circle. Can we do it? Of course yes, let's do it. First step, we join the middle point of the chord with the center of the circle. Since the chord measures 13 units, let this point be, let's say, K, and let this point be M. Km must measure 6.5 units. Okay, but we want to determine radius, right? Now, since this is a middle point, we know that a line segment passing through the midpoint of chord and center of circle must be perpendicular to the chord. So this angle must measure 90 degrees. Next, let us extend this line segment that measures 18 units to get a longer chord. Now, since this chord measures 13 units, the left out is 5 units. If you believe, then this by symmetry, this must also measure 5 units. If you don't believe, we will show it that this measures 5 units. Let us draw perpendicular from this point, let's say L. From L, we draw perpendicular to the longer chord. Okay, we did it. This measures 6.5, so does this. LK measures 6.5. So this also measures 6.5, and so does this, because after all, LM, let's say RS, LMRS is a rectangle, and so does LK TS. These are all rectangles because angles are all 90 degrees. This one 90 degree, this one 90 degree. Since it is a perpendicular and those two are parallel lines, those two chords are parallel to each other, it follows that this is also perpendicular. So all those are rectangles. So you have 1, 2, 3 rectangles. So 6.5, 6.5, 13 unit. So this one also measures 6.5, and further, since it is perpendicular, KT is perpendicular to the chord, it follows that it must also bisect the chord. So this one also measures 6.5, this one also measures 6.5. In fact, it's a rectangle, so it follows from that opposite side of rectangle are equal. Since TS measures, since T is the middle point of the chord, if it is perpendicular, then it should be that it is middle point. A line which is perpendicular to the chord must and pass through the center of the circle must pass through the middle point of the chord. So 6.5 and 6.5 is 13. So this is just 5 unit, and it follows that since these two line segments are equal, so T, let's say A and B, TA equal to TB, and TA is 6.5 plus 5, so it also follows that TB equal to 6.5 plus 5. Now, well done. Let's draw the figure once again. So we got the longer chord to be measuring 18 plus 5, that's 23, and half of 23 is 11.5 unit, and half of 13 is 6.5 unit. R is the radius of the circle. If I know this value, let's say x, then I know the radius of the circle. We can apply Pythagoras theorem. Let us consider triangle OAT. So applying Pythagoras theorem in right angle triangle OAT. R is the length of the hypotenuse. So R square equal to perpendicular square, that's x square, plus base square, base is 11.5 square. So R square equal to x square plus 11.5 square. Again, but we want to determine r, so we have two unknown r and x. We need some other relation. Observe that tk measures 6 units. This is a rectangle, so opposite side of a rectangle are equal. In fact, those two lines are parallel, so distance must be equal. And we know km to be 6.5, and this triangle KMO is again a right angle triangle. Once again we see that KMO is a right angle triangle with hypotenuse measuring radius of circle, that's equal to r, and Km equal to 6.5 and the perpendicular equal to 6 plus x. Let's apply Pythagoras theorem. So applying Pythagoras theorem in right angle triangle KMO. Let's look at the right angle triangle KMO. Hypotenuse measures r units, so hypotenuse square, r square equal to perpendicular square, so x plus 6 whole thing square, x plus 6 whole thing square, plus base square, base is 6.5 square. Now we see that we got two equations and with two unknown r and x. Can we solve for those? Yes. So we see that from equation 1 and 2 we can equate it and solve for r and x. By equation 1 and 2 it follows that you see that left hand side of equation 1 and 2 are both equal to r square. So right hand side of equation 1 and 2 must be equal. So we compare right hand side of equation 1 and 2. So first one we got x square plus 11.5 square equal to x plus 6 square, that we can expand, we can apply the formula a plus b whole thing square equal to a square plus 2ab, 2 into x into 6 plus b square plus 6.5 square. We copy as it is. So right hand side of those two equations must be equal because left hand side are both equal to r square. So we cut out x square, they are same, and take the numbers to the left hand side, variables to the right hand side. So 6.5 square we write it to the left hand side, 6 square we write it to the left hand side, 2 into 6 is 12, so 12x. Can we solve for x? Of course. Okay, we can square it or we can apply the formula a square minus b square equal to a plus b into a minus b. 11 plus 6 is 17, 17 plus 1 is 18 into 11 minus 6 is 5 minus 36 equal to 12x. Okay, now we can solve for x. So it follows that 12x equal to 90 minus 36, that's equal to 54. So x equal to 54 by 12. We can cancel out. Lastly, we need to determine the value of r. So we look at the equation 1, r square equal to x square plus 11.5 square, and solve for r. Or rather simply determine the r. By equation 1, r square equal to x square plus 11.5 square, that's equal to 9 by 2 square plus 11.5 square. So 9 square by 2 square as it is, 11.5 is nothing but 23 by 2, so 23 square by 2 square. 9 square is 81 and 23 square is 529 divided by 2 square, we write it as it is, and that's equal to 610 by 2 square. So r equal to square root of 610 by 2. That's approximately equal to 24.69 by 2. So that's equal to 12.349 units approximately.